Okay, I just went through this kind of with Vihan and Caleb, except he couldn't hear me. So hopefully this will be a little better of an explanation. So our calculation number 1, again, these are calculations just off the top of my head, very simple ones that that are easy to include but still relevant. You could, anything you can think of, 2 plus 2 is a calculation, right? So the rules give very little information about what they want. I guess they just want to see you thinking about the problem, right? So make it a calculation that makes sense. So number 1, we're gonna talk about Pythagorean theorem. So you guys, this should be review. So a Pythagorean theorem is all about right triangles. So any right triangle, when I say right triangle, I mean one of the angles here is 90 degrees. You can't have more than one of these to be 90 degrees. That doesn't make a triangle. But as long as one of these is 90 degrees, then that's a right triangle. And then you can use this very powerful theorem, right? This is used in everything, right? Like, just so many applications. This is very important, right? You'll use this if you become a historian. You will still end up using this, maybe not directly, but everything uses this. So in our case, why are we doing this? Let's say you have your device. So let's say here's a launch area, right? So your device is in this area. It's got a little barrel on it. I don't know. This is the top view, right? You're looking at bird's eye. So we have our center line here. Hopefully your barrel is aligned to the center line, right? This is not the case in this one, but let's try to do that in the competition. You're allowed. So ask the event supervisor, whenever you need to. But you're allowed to walk out here and help your partner sight. Adjust the device and all of that. But you have to get back here and you have to be behind. You can't be downrange when it's shooting. Remember, you have to announce what you're going to shoot at and all of that, right? And you guys have to be outside this launch area. Okay, sorry. This is... all my videos end up like this. Okay, this is the 8-meter mark, right? So this is the whole thing. In Boyceville, they were very nice. It was an early invitational, and so everything was on this center line. But they didn't have to do that. The rules state that you can go out 2 meters. Left or right. This is not technically to scale. It's almost to scale. Okay. So that means, right, your target could be as far as this. It could be as close as, well, it could be as close as this, but it could also be like here, right? Something like this, right? You're gonna have to turn your device like that to aim at it, right? And so, you know, there's some fudging here because, well, you know, this is your new line, right? So you have to take that distance into account, maybe. But well, actually, yeah. So that just adds even more. Because before, when you're shooting at 2 meters, you're shooting just this 2 meters. You kind of come up to this edge here, and you shoot 2 meters, and it's, you know, straight line. Now when you do it, it's still a straight line, but you're going much further. Is all, right? And so we're calculating how much further that really is, right? If it matters, I'll give you a hint. It kind of does. So we're gonna draw this triangle in our minds. So that's, I'm not gonna draw arrows, I guess. This is a triangle, that distance and this distance, and we're gonna call it like that right now, instead of something more like, you know, like coming from here, just because we kind of don't know what this fudge factor is. So we're going to ignore that, but that is another thing to keep in mind as well, and that's also not insignificant. We're going to say this is 2 meters, this is 2 meters, and this is what? So Pythagorean theorem states, if we call this leg A, we call this leg B, we call this leg C, A squared plus B squared equals C squared. Or another way to write it, C equals the square root of A squared plus B squared. Right? Very powerful, works with any triangle as long as it's a right triangle. Sorry, works with any right triangle, but that's very important. It's right. But it works with any of them. So you know, this could be 5 and this could be 12, and this ends up being 13. That's a special one, because it's a nice number. You know, it's exactly 13. But this could be, you know, 3 and 4 and 5, or this can be like 1, and this could be 100, and this would be the square root of 1 squared plus 100 squared, right? Which is 101, which is very close to 100, right? So the further apart these get, maybe the less it matters, right? If we go through this 2 to 8, then this is still 2, this is 8. This is the calculation that we just did in the Zoom meeting. So you get the square root 2 squared plus 8 squared, and that gives you what? Sorry, you're not here. Square root of 68 is around 8.25, I think. .25, yeah, meters, right? That doesn't sound like a lot, and really it's not a huge deal, but this is still within like this is 24 centimeters, right? 24 centimeters more than you would have gone if you had just gone for along the center line. A bucket shot, which is worth a lot of points, is around 30 centimeters in diameter. I'm going to use meters. It's around 0.3 meters in diameter, right? Which means that this radius is 0.15 meters. It's half of that. So if you initially were going to, like, let's say you were going to get it perfect right in the center here, but you didn't do this calculation, you would have actually fallen short you would have fallen short 0.24 meters, and you would have missed the bucket by 9 centimeters. Right. So that's to give you an actually, right, if we're really kind of drawing this correctly here, the whole point of this is you would have missed it over here. It would have been because this distance is also 0.15. Okay, that's maybe enough of a tangent for you. We can do this 2 and 2 meters as well, because this is a much bigger deal in the grand scheme of things, right? So again, it's just the square root of 2 squared plus 2 squared, which is the square root of 8, which is, I should know that one, but don't, 2.83. Right, and now that's, you can see that's a big portion of your overall distance that you're traveling, right? That's almost half of what you would have shot, right? So this 2, if you can kind of imagine a circle around your point, that's like 2 meters. Whoa. I don't know. Oh man, I had it. Okay. Right, so we're saying, like, if this is the starting point right here, and you have a you have a 2 meter range, right? So you would have shot there. If you get this, even if you get this perfectly aligned, you would have fallen short by, oh my god, by 0.83 meters, right? And that's huge. That doesn't even qualify you for a bucket shot. That's like more than 2 feet. Okay, that's enough of a tangent for one thing. So we can move on really quickly to the next one. Again, feel free to fast forward through all of this, whatever. Calculation 2 is it's called linear interpolation, right? So you can look this up if my thing is too confusing for you. Linear, there's plenty of videos online. Interpolation, right? So let's say you have you've nailed all your whole meter increments, right? So you have data for 2 meters, 3 meters, 4, 5, 6, 7, 8 meters, and you have loads of data, right? You've been every time we've been practicing, you've just been hitting those. Or let's say, actually, maybe that's not so reasonable, because we've been definitely going for half meter increments, but we haven't been doing anything past half meter increments, right? Remember, the rules say when you get to state level and national level, if you guys end up going to nationals, they have much finer increments, right? So I believe, I don't know this, but I believe it's 0.25 meter increments, and then for states, and then 0.1 meter for nationals. So anyway, let's say okay, we win regionals. Now we have states that we have to compete in, but we haven't really been doing 2.25 meters, right? Let's say 2.25 meters. That comes, oops, that lands, you know, kind of between these two. And for some reason, you know, we've made it through regionals. You've just don't have time, or something happens, and you never get around to doing this 2.25 to prepare for states. So this is how we're gonna calculate. So let's say our data is being perfect, right? So let's say, you know, for 2 meters, if we want to travel 2 meters, then our angle of our barrel is 10 degrees in the air. I don't know what it is, and I don't want you guys to use these numbers, because I'm making up these numbers, right? So use your data, right? Because they're gonna look at this at the numbers that you have, and they're gonna be like, where did you get this? You know, why are you doing these calculations? Do calculations that actually matter. So you know, yeah. 2 meters is 10 degrees. 2.5 meters is 12.5 degrees. That seems like a pretty big jump. So again, like, we should talk about this a little more. The angles, a very small difference in angles gives you a very big difference in output. And most of the other people are not changing their angles very much, right? They're using weights, different weights, or different like heights of weights, as a way to change their distance. And we should talk about that more, because I think they're onto something. It has to do with the shape of a sine wave. But let's say that these are the numbers, right? So your input is 12.5 degrees, and you get 2.5 meters. You know, it's never going to be exact. Let's say it's 2.54 meters. And let's say this is 1.85 meters. All right, this is still pretty close. This is very close. This is decently close, right? That's like a bucket shot, almost. It's like the rim of a bucket shot. And with just this, we're gonna predict where 2.25 meters falls in here, right? So it lands somewhere in here. So your angle is gonna be somewhere between these two, right? Be somewhere like that. We can draw this graph to maybe help visualize this. Our input is 10 degrees. This graph is not to scale. So our input is 10 degrees and 12.5 degrees. And when we do that, we get 1.85 meters. Aye. And 2.54, right? So you know, you can look at these points. You can draw a line between these points, right? And we're gonna assume that that's what's happening, right? In real life, like I said, this is a sine. It's not a straight line, basically. But if you get points close enough together, right, then it should give you a good idea of where to start, right? If they don't end up liking these sample calculations for Miralama, we can get into a little bit more complicated sine stuff later, but it should be fine. So again, 1.85. this is going to be a little closer to, this 2.25 is going to be a little closer to the 2.54. And so we're going to end up looking at somewhere right here, right? But again, we still don't know. And again, see how this is, it's closer to 12.5 than 10 point, or than 10 degrees, right? That's all this is, right? That's the whole point of this, is you're saying you're going to take this jump, right? So 2.25 minus 1.85 is 0.4 meters. And this whole jump, 2.54 minus 1.85 is 0.69 meters. If I do arithmetic wrong, please just do it right yourself. I don't know how to count. So so this is a certain fraction of this overall thing, right? And all we're doing is, so let's calculate what that fraction is, right? 0.4 divided by 0.69 gives you 0.58, or maybe a better way to think about it is 58%, right? So if this is a straight line, then if we go up this amount, these are different units, right? So you can't compare like a meter to an angle. I mean, not in this context, but you can compare like percentages of how much you increase and how much you increase here, right? Between the same 2 points. And so we say that we're this 2.25 is 58% above this 1.85. Again, it's 58% of this whole thing, right? So, you know, without all three of these points, these numbers don't make sense. It's just, you know, you can't say that. Yeah, I think you get that. All right. So we're gonna calculate how much 58% is of this gap, right? So our gap here is, let me give the whole picture. So our gap here is 12.5 degrees minus 10 degrees. 2.5, I can do that one. So 2.5 degrees, and we want to find 58%, oops, sorry, of 2.5 degrees, right? So again, of means multiply, maybe you guys know that already, and a percent is this decimal point, right? So 0.58 times 2.5 gives me 1.45 degrees. We're going to round up, well, 1.45. We're going to round up to 1.5. You notice these are either half a degree or a whole degree, because that's kind of the increment that you guys have been working with, and even that is a little shaky. but yeah, you can kind of tell when a string is half a degree, you know, between two tick marks. I don't think I'd be able to tell if it was a third or something like that, right? Or 0.45. So 1.5, and that's pretty close to 1.45 anyway. But this, again, like we're not, 1.5 doesn't give you 2.25. It's just 1.5 in addition to this 10 degrees, right? That's a bad way to say it, but as we're increasing, as we're going on this line, we're increasing this angle by 10 this 10 degree angle by 1.5 degrees, and that gives us an increase in meters of 0.69, or sorry, 0.4 meters. Right there again, you see this right triangle right here. Pythagorean theorem. All right. So what is 10? Wow, I don't know what just happened there. What is 10 degrees plus 1.5? Gives you 11.5 degrees. And again, these numbers are grabbed from thin air, but you know, if you had to guess, then this would be a good guess for you know, your starting point for 2.25 meters. Oops, sorry, meters. Okay. I think those are solid calculations, especially for right now for Miraloma, for you guys to kind of work through. If you have, so I would write down, you know, I don't know what you want to call this calculation, but you're using the concepts that you're using are the Pythagorean theorem and the linear interpolation. It's not the linear, it's just linear interpolation, right? It's linear because it's a line between these 2 points, and interpolating is finding. Inter means like between, so you know, finding a new point between the 2 points. So anyway, I would write those in your calculations kind of like this, just to let them know that that's what you're doing. And then otherwise, I think this is fairly self-explanatory. For this one, I would draw this diagram. You know, it doesn't have to be beautiful. For this, I drew this graph because I think it's helpful to visualize, but you don't necessarily have to draw it. You can just kind of go through, you know, all of this. There's a, if you look up linear interpolation online, I'm sure you'll find formulas that basically do all these things. I didn't make it into one big formula because I wanted to break it down into things that actually make sense. So I think this might be a little easier to follow. But let me know if you have any questions, please. Otherwise, I will see you guys tomorrow for more testing, and then Saturday at the competition. We're going to impound at 7:30, right? So we want to be there at 7:30 at the very latest, right? We only have half an hour for impound, 7:30 to 8 a.m. So we don't want to be the last ones in, you know. It'll take some time to go through people, so we want to be like in line ready at, I don't know, 7:15, 7:20, something like that. We might again take a little time to see if our devices are working properly before we impound, and so that's fine. But also, Caleb and Layla are going to, and I, maybe it's just, well, yeah, all three of us, all four of us with Coach Tong, we'll go to the event supervisor even before impound, right? Even before we meet and set up the device, you know, check the device is working. So 7 a.m. kind of thing. and we're going to talk to them about the scheduling conflict. We're going to try to get a time slot that works for everyone. So I believe that's 10 a.m. or 10:30, I forget. Yeah, sorry, went on way too long.